Maybe it's a bit over the top, but the Viper engine out of the Provost has a starter panel. You simply just press a button and it goes through various stages automatically from a panel. But it doesn't use electronics on the original aircraft. It uses a small rotary electric motor with cams operating little micro switches, which runs for 34 seconds, putting the various supplies onto the rate reset valve, fuel starting valve, the high energy ignition units, etc. I haven't got any of that. I haven't even got the starter system that attaches to the front of the engine, so I had to make all that first. So we've seen that on earlier videos. So I set to designing and making my own start panel. I could have simply put a button in the cockpit to set the motor going, but it would still have needed some contactors to get it through the various stages of resistance to start it up gradually. And then I had to have pressed switches in certain orders, rate reset valve, and then waited a few seconds and put the igniters on and then the starting solenoid, and so on, having to think and get those procedures right. So rather than do that, I thought I will build a panel so that it will do it automatically, the same as the original, or as near as possible to the original starter panel. That had a no volt coil or relay, or no current relay in it, held in by the motor current. So when that motor current drops, as the speed increases and the motor gets spinning, eventually when the engine's fired, the voltage and current so low the relay drops out and stops the motor. Well, I've got none of that, so I've had to do it with timers, and these timers are a bit limited in the functions that they will do. There's two functions: either it comes on immediately, you press the button, and you release the button, it then sets the time for how long it stays on, then it drops out. The second function it will do is a delay. When you press the button, it puts there's a delay with the timer before it comes on, which I've used on the second and the third relays. So they are delay before on. The problem is you can't set them to switch off as well. Can't have the delay and then it comes on for a set time and then it goes off. It won't do that. We'll only do the one function, which is a delay before it comes on, which was needed for the second and third ones. That one comes on with the on immediately function. So immediately I press the button, it sends a pulse to the timer relay for that number one contactor, puts it in, and then 5 seconds or so later on the delay one, that comes in. Then about 6 seconds or so after that one comes in. But I've held that one in for about 22 seconds so that it puts a supply onto the relay for the high energy and the fuel valve relays, but they don't energize. It's on the common side. They don't energize till the second timer comes in, and that sends a trigger, that timer sends a trigger to that contactor, so that contactor comes in, speeds the motor to second speed, but it then energizes the high energy relay and the fuel valve relay to start the engine. They're shown here by, that's the fuel valve light, and I've got the high energy lights here. I'll do another run through in a minute. So those are the high energy supply to the units, and that's for the starting fuel solenoid valve. I've got a motor run light, but I've only put it on the final contactor. I didn't want to put it across the motor terminals connections where it would be on as soon as the first stage and second stage came in, because I'm using two different sets of power supplies. I'm having some onboard batteries for all this control circuit, because electronics are sensitive to voltages. I'm a spark by trade, so I know a little bit. And I thought that if I use the same batteries for the motor load, when that comes on it will drag the voltage down somewhat, and that could affect the functioning of the timer relays. So the timer relays are all on onboard batteries, smaller ones, in fact they're there on the floor, just ordinary car batteries, and that's working all these timing functions. So the motor will have its own plug-in auxiliary batteries which will feed onto through this resistor when I've got it connected up. I've yet to do that with the heavy duty cables. So that goes out to the motor, and then when the vehicle's running, then that battery can be plugged out and the onboard batteries will stay on, so I've got communication radio in the cockpit and other little bits and pieces. So that's basically the system. To make those timers second and third, that's the timer, those are contactors. Timers for that is there, the timer for that one is down here somewhere, that one. To make those stop, what I've done is to feed those, or the triggers for those, what triggers them is the rate reset valve timer. So that energises for the whole 34-second period. So that goes in straight away, puts the feed on the rate reset valve, isolating solenoid on the engine, and at the same time it puts a trigger onto those two timers, that one and that one, to those two contactors, so there's a delay before they come on. Now the fact that they stay on, or that stays on, when the third one comes in doesn't matter, because electricity takes the path of least resistance. So even though that remains in, when that third stage contactor comes in, it shorts the resistor out completely and the motor speeds up. Electricity takes the path of least resistance through that direct feed from that incoming supply onto the contacts. So it doesn't matter if that stays in, because it will bypass it, and it's the same for that one, which I've kept that one in so that it can, when it de-energises, it takes the power off the high energy and the fuel valve relays at the end of its run, which is about 20 seconds there, so that when that comes in, it doesn't bring them in immediately, it only puts the common feed onto those, and they come in when the second stage timer operates that contactor, then they trigger. But to make them drop out as well, which the timers wouldn't do, to make them drop out at the end of the 15-20 second period, I've made the common feed for them through that number one timer relay, so when that de-energises after its set time, those will drop out. The fact that's still in when that comes in, again, as I say, is irrelevant. Electricity takes the path of least resistance. So I've got a main power on off. I don't know if you can quite see that on the camera. I'll move the camera around in a minute. So that puts the main power on to the panel. Then I'll have these cables here will be in a loom into the cockpit, done properly. I've just got it set up loosely here at the moment. So that puts the power onto the cockpit. So when I press that button to start it, I've got a clock here so I could be clocking and setting up all the times accurately. It's taken me a while to do it, and it's taken a hell of a job to do the diagram. So when I press that, immediately that will go in, first stage, and the rate reset valve will energise. Then, I don't know if you can see these readings on here, probably a bit far away and not very clear, these digital meters. But that will change to a 0 as that energises, that will change to a 0 as that energises, that analogue one will go across there when that energises. And then after a set time, these two will come on, high energy units, with the starting fuel, and then you'll see them go off. So, set that going, rate reset valve energised, that's gone in, Second one's gone in, and that's lit up the ING units and the starting field solenoid. Third stage has gone in. That run to the end of the sequence, which is 34 seconds, fed off the rate reset valve relay, and that was the time. The timer's dropping out for the ignition and starting fuel solenoid. The stage 3 is still in, the motor running light's just gone out, rate reset valve's gone off, and that's it, back to normal. So after that time, engine should be running. If it's not, I have to stop and have a look and to find out why. It's an old engine, so I'm hoping the valves and other things, solenoids are working okay on the engine. I couldn't run the engine when I first got it because there was no means of spinning it, so I've had to construct a chassis around it, so I had a structure on which to hang my starting drive dogs and the motor and everything else. So maybe I should have run it first as recommended by somebody, but wasn't in a position to do that. So there we have it. I'll move the camera around it in a minute and do another button start. That's my homemade wire wound resistor and ceramic insulator. I was quoted £200 to make ceramic insulator, and I shopped around. I couldn't find anywhere else to do anything any cheaper, so I decided to make my own. Nobody's asked me how I made it, which I found rather surprising. So I used 4 cups, small cups. I've managed to get some the right size, parallel ones, and fasten them together with a special cement. And I wound the resistor out of 4mm stainless wire 316. I'll need to check if it gets too hot. I might put a second resistor in. That's why I've left a gap below it, just in case. But if you put 2 resistors in parallel, it halves the resistance. Now at the moment I'm only using that much from there to there. That's the stage 1. And then that shorted out, goes on to that resistor, and then that shorted out and the feed straight through. So if I put a second resistor in parallel with that, it will halve it, so I'll double up and use the full length of it and the full length of the other one. So that's what that is for. I can keep this camera still. I'll see you the first one. Let's energise the second one. And the third one. I don't know if you can see that analog meter. That one's dropped out now. Well, it should in a minute. Yeah, that's dropped out. That's the end of the cycle. So, there we have it. That is the drawing I've made. I had to sit down and design it, working off how these timers would work, and working off the Rolls-Royce workshop manual on other bits and pieces I've gathered as to how the system worked, and then design a circuit to make those timers, which were a bit limited in their function, do what I wanted them to do, to follow as near as possible to the original starter. So I've not got to keep pressing switches. All I've got to do is sit in the cockpit, press one button and have it done itself automatically. I've got to fit the exhaust system on yet, make fuel tanks, drain tank and other bits and pieces, control cables for the throttle and high pressure fuel on and off and so on. So there's a bit of work to do yet. Cheers for now.